This recording is for my grade 12 students for the work that has been posted on Teams. I'm going to walk you through how to solve question 1 and in a separate video how to solve question 2. So let's start with this one. There are charged spheres that are fixed in the positions as shown. There is sphere A, sphere B. Calculate the net force on sphere C. Now, I just noticed that the drawing does not show which one is sphere A, sphere B, and sphere C. So I will specify that this one on the left, which is positive, is sphere A. This one in the center is a sphere B, it's negative. And this one is a sphere C. There are distances as shown. So let's solve this one. C. If the charges are the same, which is A and C, the spheres would repel like so. If the charges are opposite, like sphere B and C, the spheres would attract. So now what we need to find is the net force acting on sphere C. So we basically just need almost to look at this section separately. I don't know which force is larger, which force is smaller. So let me name this force is A acting on C, and this force B acting on C. So the net force is the sum of these two forces. Now I want to introduce some axes, let's say positive axis facing as shown. And I will say that if my calculation yields to a positive result, that the net force will be pointing to the right. If my calculation yields in the negative result, the net force will be pointing to the left. The BC force is opposite of my chosen direction. AC force is positive. And now the Coulomb's law. In general, force is coefficient K, charge 1, charge 2, divided by the square of the distance. So force BC will involve charge B, charge C. Force AC will involve charge A, charge C. So F net. Coefficient K will be the same in both cases. And it is actually equal 9 multiplied by 10 to the power of 9 Newton meter squared, Coulomb squared. So let's see, minus K, charge B times charge C divided, what is the distance between B and C? We have to refer to the drawing. It's 10 centimeters, which we need to convert into meters. How about I put 0.1 squared plus K, charge A, charge C. The distance between A and C, let's see, 20 plus 10. So it will be 30 centimeters or 0.3 squared. Now I know it's unusual to put some letters and some numbers, but I just don't want to introduce distance and call it. I could technically. I should have written R between AC, R between BC. So now F net put K outside, and I put, I don't like this minus at the front, so I'll start with this QA and QC. QA is 4, but I use the dot. 10 power negative 6. QC 6.4. 10 power, this is 10 power negative 6. I apologize that I'm ignoring units of measure. 0.3 squared. QB 2.5. 10 power negative 7. QC 6.4. 10 power negative 7. 0.1 squared. Again, some thinking here. So now all we need is just to put this into the calculator and see what we have. If our result is positive, in other words, if this first term is greater than the second term, then Fnet will be pointing to the right. Okay, so what do I have? 9, 10 power 9, 25.6, 10 power negative 12. The calculation part is really your choice how you wish to proceed with that. Maybe you have scientific calculators who do all the job, or I personally prefer to do a step-by-step calculation. So 9, 10 power 9. I take 10 power negative 12 outside of the brackets. 25.6, 0.009. Because I take negative 12, I leave 1.6 here. 0.1. Okay, so overall, I have 9, 10 power negative 3, and in brackets, looks like 124.44, which leaves me with 1120, 10 power negative 3, or 1.12 newtons. And yes, it is positive, hence the force is pointing to the right, meaning that the repulsion, the pink vector, is stronger than the attraction, than the blue vector. So Fnet is pointing to the right. Let's circle this answer like so. Now I know in the answer it says 1.2. I copied it from the book, and the way they got it, they calculated each force individually. They rounded up during the calculation, so it is possible. Or maybe I miscalculated something. I did check several times, so I'm pretty confident though. So that's how we would solve this question. I'll post the video into the Teams now.